So we're looking at a paper today titled Measuring the Gap Between Human and LLM Research Ideas by Ziyu Chen, Yilun Zhao, and Armin Cohan from Yale and U Chicago.
Right.
And for everyone watching this installment of AI Paper Slop, I'm just going to give you the TLDR right up front.
Let's hear it.
When you ask a large language model to brainstorm a new research idea based on prior papers, it defaults heavily to a highly specific, narrow template of just stitching existing concepts together.
Yeah, it's very repetitive.
Exactly. While human researchers distribute their ideas across, diverse local interventions like replacing a broken mathematical mechanism or decoupling confounded variables, LLMs just overwhelmingly generate these bridge opportunities and synthesis methods. And strikingly, giving these models the full text of the papers instead of just abstracts, it doesn't fix this. And turning on the thinking or reasoning modes in models like Qwen and DeepSeek actually makes their ideas significantly more generic and less human-like.
Yeah, which is, it completely inverts the standard scaling laws we rely on, right? Because in almost every other domain, providing a model with more context window or, dedicating more inference compute to reasoning, it naturally leads to higher quality, more nuanced outputs.
You think it would get better?
Exactly. But this paper systematically proves that for this specific task of scientific ideation, current models are trapped in this mode collapse of synthesis.
So if standard prompting just yields this generic buzzword soup, I guess the natural question is how we actually quantify that, right? Because to understand why LLMs are stuck in this synthesis loop, we have to look at how the researchers managed to objectively measure something as notoriously subjective as research taste.
Right, because taste it's so hard to pin down. But they started by building a massive interdisciplinary data set. We're talking 11,683 published human papers.
Wow, that's a lot.
Yeah, and it covers top-tier machine learning conferences, so ICLR, ICML, NeurIPS, as well as natural science papers from Nature Communications. But, just having the papers isn't enough.
Because you have to control the environment, right?
Yeah.
To isolate taste, you need to present the human and the AI with the exact same starting conditions.
Precisely. If you just ask an LLM, hey, give me an ML research idea, it's going to sample from its entire pre-training distribution.
Yeah, it could pull from anywhere.
Right. You wouldn't be comparing its problem-solving approach to a specific human's approach. You'd just be testing its topical recall.
It's kind of like giving two chefs, one human and one AI, the exact same basket of ingredients.
Yes, exactly that.
You want to see if they bake the same type of cake. It eliminates the whole variable of topic choice and isolates their actual taste in problem solving.
That's a perfect analogy. So to get that basket of ingredients, the researchers built an extraction pipeline to reverse engineer the precise context the human authors had when they came up with their idea.
Okay, how do they do that?
For every single one of those 11,000 papers, they analyzed the citation graphs and the text spans to isolate 4 to 8 highly relevant prior works. They weren't just pulling the general literature review background citations. They were computationally identifying the core foundational papers that directly motivated the methodology of the target paper.
So they essentially built a localized context window for every human breakthrough in the data set.
Exactly.
They found the exact stack of previous papers the human authors were heavily referencing right before they had their light bulb moment.
Right. And once they had that highly specific stack of prior works, they fed the titles and abstracts of those exact same papers to a suite of LLMs. They used Claude, Gemini, GPT, DeepSeek, and Qwen.
The heavy hitters.
Yeah, all of them. And the prompt simply asked the models to generate a novel research idea based on those specific references, broken down into a motivation and a method.
But wait, comparing a human abstract to an LLM generation textually that feels inherently noisy, how did they standardize these outputs into something mathematically comparable?
That's where they introduced this two-axis research taste taxonomy. Axis 1 is the opportunity pattern. This defines the why.
Okay, like why this study is needed.
Right, exactly. Why is a new study needed? So they categorize these motivations into specific bins. You have finding a puzzle or contradiction in the prior work, finding an explanation gap, identifying a scope mismatch, hitting a resource bottleneck, identifying a risk or failure mode, or, and this is the big one, a bridge opportunity.
A bridge opportunity. That means the researcher basically just noticed two disconnected literatures and decided to connect them.
Exactly. Here's literature A, here's literature B, let's smash them together. That's the bridge opportunity.
Okay, so that's axis 1, and axis 2 handles the implementation, right? The how.
Correct. Axis 2 is the method paradigm. It captures the structural style of the intellectual contribution.
Like the actual mechanics of the paper.
Yeah. Are you doing a synthesis or unification of ideas? Are you relaxing a scope constraint? Doing robustification? A formal derivation? Empirical mapping? Or simply building an artifact or system? By mapping tens of thousands of human and LLM ideas onto these specific discrete bins across those two axes, they basically transformed subjective textual ideas into probability distributions that you can directly compare.
That's super clever. So when you actually look at the probability distribution of the human ideas versus the LLM ideas given the exact same starting materials, what does that delta look like?
The distributional gap is staggering. Just staggering. Let's look at the opportunity axis first. For the human ideas, only 12.1% were motivated by a bridge opportunity.
Only 12%.
Yeah. Humans generally distribute their motivations pretty evenly across finding bottlenecks, explanation gaps, contradictions, things like that. But for the LLMs across the board, that bridge opportunity number skyrocketed to between 47.1% and 64.2%.
Wait, really? Over half the time, regardless of the papers provided, the LLM just defaults to saying, hey, these two things haven't been connected yet.
Yes, over half the time. And that carries directly over to the method axis, too. Only 5.1% of human papers used explicit synthesis or unification as their core methodology. The LLMs, they used it between 22.5% and 38.7% of the time.
That is a massive skew. And to put some rigorous numbers to this, I know the researchers evaluated the distributions using a few specific statistical metrics. Like they looked at normalized entropy, right?
Right, normalized entropy.
Which basically measures how uniformly a source distributes its ideas across all those taxonomy categories.
Yeah.
If you have high entropy, you're exploring a wide variety of problem-solving techniques.
Yeah.
But if you have low entropy, you're concentrated heavily in just one or two buckets.
Exactly. And the LLM ideas had significantly lower normalized entropy than the human ideas across almost every single model they tested.
And they also use total variation distance, or TVD.
Yes, TVD was a major metric here.
For those tuning in who might be unfamiliar, TVD essentially measures the L1 distance between two probability distributions. It basically tells you exactly how much probability mass you would have to physically shift around for the model's distribution of ideas to match the human's distribution.
Right. And the TVD numbers were massive. I mean, even the best performing model on the opportunity axis, which was Gemini 3.1 Pro, it had a TVD of 0.348.
0.348. So that means nearly 35% of its generated ideas would need to be completely recategorized out of that synthesis bucket and into things like formal derivations or empirical mapping, just to match the baseline human distribution.
Exactly. 35% is a huge shift. They also measured Jensen-Shannon divergence to capture the smoothed, symmetric difference between the two distributions, and the results confirmed the exact same severe misalignment.
So the distributions are totally out of whack.
Yeah.
But to dig deeper into the actual textual quality of these ideas, they didn't just look at the taxonomy bins, did they?
No, they went further.
They ran these ideas through an automated annotator to get diagnostic scores. And I know the immediate red flag for anyone working with LLMs as a judge is that they are highly biased toward their own outputs.
Oh, absolutely.
So how did they calibrate this to ensure they weren't just getting, noisy, self-congratulatory scores from the models?
It's a critical point, and they handled it well. They didn't just use a zero-shot prompt and ask an LLM to rate the ideas 1 through 10. They built a highly calibrated pipeline using few-shot prompting, and they grounded it against a human-annotated held-out set.
Oh, okay. So it was anchored to human ratings.
Yes, and they explicitly evaluated the ideas on 3 very narrow diagnostic dimensions: boilerplate phrasing, surface stitching, and bottleneck specificity.
So it's looking for highly specific structural flaws in the text, not just a general vibe check.
Right, exactly. And the results were pretty damning. The LLM ideas consistently scored significantly higher for boilerplate language. They read like generic grant proposals.
Yeah, we've all read those, right?
Right. And they also scored much higher for surface stitching.
Which is what, exactly?
The researchers defined it as superficially slapping 2 prior concepts together without proposing a novel mechanism for how they actually integrate.
So just saying, we will combine X and Y without explaining the math of how X and Y actually talk to each other.
Precisely. And then on the flip side, they failed on bottleneck specificity.
Spectacularly, from what I read.
Oh, yeah. Bottleneck specificity measures whether the idea identifies a precise mathematical, architectural, or empirical limiting factor in the prior work. The LLMs scored terribly here. They rarely identified a specific broken component.
Though, wasn't there one exception?
There was. Claude 3.5 Sonnet actually showed slightly higher bottleneck specificity than the human baseline, which is interesting. But even then, its overall taxonomy distribution was still heavily shifted toward the generic synthesis template.
Okay, let me play devil's advocate and challenge the premise of this entire evaluation for a moment. Is synthesis actually a bad thing?
It's a fair question.
Because if you look at the history of science, and specifically the last decade of machine learning, a massive percentage of our greatest breakthroughs come from interdisciplinary synthesis, right?
Definitely.
I mean, combining reinforcement learning with language modeling gave us RLHF. Combining diffusion with latent spaces gave us stable image generation. Are the models just acting like highly effective interdisciplinary researchers, or are they really taking a lazy shortcut?
The paper addresses this nuance directly, actually. Synthesis itself is a valid, vital scientific move. The problem isn't the existence of synthesis. The problem is the artificial narrowness of the distribution.
So it's about the ratio.
Exactly. An AI scientist agent is practically useless if it applies the exact same contribution template to every single problem it encounters.
Right. If every problem looks like a nail, the only tool it knows how to use is the synthesis hammer.
That's it, exactly. By forcing every set of prior papers into a bridge opportunity, the model is ignoring 80% of the actual mechanics of scientific advancement. It is entirely ignoring empirical mapping, it's ignoring the need for formal mathematical derivations, and it's ignoring the identification of subtle systemic failure modes. It just wants to integrate.
It just wants to mash things together. So if the models are over-relying on this synthesis template, what does the anatomy of an LLM idea actually look like under the hood compared to a human idea?
To figure that out, the researchers ran a mechanism analysis. They used archetype clustering to isolate the main operations, basically the core verbs driving the proposed methods.
What were the LLM verbs?
For LLMs, the operations are overwhelmingly clustered around verbs like integrate, unify, adapt, merge, and design. Just the word integrate alone appeared as the driving verb in over 34% of model outputs.
34%. That is a massive centralization around a single operation. What was the human equivalent?
For human researchers, integrate showed up in just 2.3% of the ideas. Yeah. Human proposals are overwhelmingly dominated by local surgical interventions. Their verbs are replace, decouple, formalize, and separate. For instance, the verb replace made up over 9% of human operations, but it barely registered at less than 1% for models.
That's wild.
And the operation decouple was used by humans over 10 times more frequently than by any LLM.
It essentially maps perfectly to the difference between, like, playing Mad Libs and doing actual wrench work.
Oh, that's a good way to put it.
The LLM is basically playing scientific Mad Libs. It scans the prior papers, extracts the loudest terminology, and generates an output that says, let's integrate concept A with concept B.
Exactly.
Meanwhile, the human researcher is, opening up the hood of the prior work with a wrench, pointing at a specific broken gear and saying, we need to decouple these two confounded latent variables to fix the vanishing gradient.
That is a perfect visualization of what the data shows, and we can see this even more clearly when we look at their analysis of concept enrichment. They isolated the core technical concepts that models latch onto versus the concepts humans latch onto.
And what do they find?
The models overwhelmingly enrich high-frequency, trending technical motifs. They grab concepts like multi-omics, diffusion policy, multimodal generation, in-context learning, test time adaptation.
So it's just indexing the most heavily weighted buzzwords from its pre-training data and forcing them into the prompt's context.
Precisely. They grab the most salient, trending macro concepts and they just wrap them in those safe integration verbs.
And the humans.
The human-enriched concepts are much narrower. Humans index on specific functional mechanisms, trajectories, ligands, tokenization, equivariance. They name highly specific variables and constraints that they plan to physically alter.
There is a really elegant way to visualize this difference that the researchers mapped out using the geometry of the ideas in an embedding space, right?
Yes, the embedding analysis.
If you think about the provided prior papers as vectors pointing in different directions in a high-dimensional latent space, the LLM's proposed idea almost always acts like a regression toward the mean.
Yes. The LLM proposals sit diffusely right in the middle of all the prior papers. They suffer this gravitational pull toward the centroid of the provided context.
Because they are just synthesizing, their embedding is essentially an average of the inputs.
Exactly. Human proposals, however, have significantly lower entropy over the prior works.
Meaning they take sharp orthogonal vectors.
Right.
They align heavily with maybe one specific prior paper to critique it and diverge sharply from the others, taking a distinct stance rather than to just smoothing everything out into a centralized average.
And that structural smoothing is the absolute hallmark of the LLM generation process.
Which naturally brings up the engineering question. If standard prompting yields generic buzzword soup that collapses to the centroid of the latent space, the immediate instinct for any ML practitioner right now is to just throw more context and more compute at it.
Of course, that's the current meta.
Right. Give it the whole paper or turn on the new reasoning models. So did forcing the model to read more or to think break it out of this template?
This is where the results get highly counterintuitive, and it's arguably the most actionable insight for engineers building these pipelines. Let's look at the full paper context ablation first.
Okay, so feeding it the full text instead of just the abstract.
Right. The initial hypothesis was that providing just titles and abstracts starved the model of the technical depth required to propose that local wrench work you mentioned. So they fed Qwen 3.8b and DeepSeek v4 Flash full text summaries of the prior works instead.
And it didn't change the distribution.
It actually made it slightly worse.
Worse.
Yeah. The total variation distance in Jensen-Shannon divergence from the human baseline actually increased. Giving the models thousands of extra tokens of deep technical methodology didn't change their fundamental approach to problem solving. They still extracted the macro concepts and proposed a bridge opportunity.
Okay, what about the prompt itself? If you ask an LLM for a coherent novel research idea, the RLHF tuning might interpret coherent as a command to heavily synthesize.
They thought of that too. They ran an ablation on relaxed prompting as well. They stripped out any words that might subtly imply synthesis, integration, or unification using highly neutral terms. It barely moved the needle. The tendency to organize around bridge-like opportunities remained completely stable, proving this isn't just a superficial artifact of the system prompt.
Okay, so more context fails and prompt engineering fails. What about inference compute? They tested the new reasoning and thinking modes in Qwen and DeepSeek. And you noted at the beginning that this actually backfired.
It was the biggest failure of all the ablations. When they turned on the reasoning mode in Qwen 3.8b, its reliance on bridge opportunities jumped from an already high 49.7% to a massive 71.1%.
Wow.
The normalized entropy just plummeted. The ideas became overwhelmingly concentrated into a single categorical bucket.
Let's unpack the mechanics of that, because on the surface, that makes no sense. Why would giving a model chain of thought tokens time to logically evaluate its own ideas make it significantly worse at diverging from a basic template? Shouldn't unrolling more tokens allow it to explore the latent space and find those orthogonal, unique human angles?
That assumes the reasoning mode is searching for novelty or diversity. It's not.
Oh, right.
Chain of thought is optimizing for the baseline objective it was trained on during reinforcement learning from human feedback. In RLHF, reward is heavily correlated with human preference for coherence, fluency, and perceived safety. Proposing to integrate concept A and concept B is incredibly safe. It is logical, it sounds highly coherent to a human rater, and it is easy to justify in text.
Ah, I see. If it proposes a novel mathematical derivation or suggests decoupling a specific latent variable, it risks hallucinating a structural flaw. It risks generating math that doesn't actually work, which would penalize its reward during training.
Exactly. When you give the model extra inference compute to think, it doesn't use that compute to rethink its approach and say, maybe I should try a local intervention. It uses the extra compute to make its default integrate template absolutely bulletproof.
So it's just rationalizing the lazy answer.
Yes, it spends its chain of thought tokens optimizing the justification for why integrating those buzzwords is the safest, most logical next step. It sharpens the mode collapse instead of escaping it.
It's optimizing for verifiability over actual scientific utility. It knows synthesis is a statistically safe bet that sounds intelligent, so it just thinks harder about how to perfectly justify the synthesis.
Which means reasoning models, in their current form, are not a panacea for the diversity or the taste of scientific ideation. Throwing inference compute at an alignment problem just makes the model better at executing its misaligned default behaviors.
So if you are an AI researcher or an ML engineer tasked with building the next generation of AI scientist agents, this requires a fundamental reframing of how we evaluate models, doesn't it? You have to stop treating ideation as a single-turn fluency test and start treating it as a distributional alignment problem.
That is the core takeaway right there. You
Yeah.
cannot evaluate LLM outputs in a vacuum. If you generate a single research idea from one of these reasoning models and you evaluate it on its own merits, it will likely look fantastic.
Because it's coherent.
Right. It will be a highly polished, deeply coherent synthesis of existing work. It will easily pass a basic qualitative review.
But if you evaluate the portfolio of its outputs,
Exactly. If you ask an agent for 50 ideas across 50 distinct scientific contexts, and 45 of them are just integrate X with Y, you haven't built an AI scientist. You have built a very eloquent stapler.
an eloquent stapler, that's brilliant.
It is just pinning related papers together. We have to figure out how to alter the reward functions in our models to incentivize the dirty, specific wrench work of science. We need models that are willing to identify brittle components, formalize local structures, and decouple confounded variables, rather than just playing a high-dimensional game of buzzword Mad Libs.
And this paper provides the exact methodology and taxonomy needed to benchmark that progress. As we train new reasoning models, we can now mathematically quantify whether an agent is actually adopting a human-like distribution of research taste or just finding more sophisticated ways to collapse to the centroid.
Right. It gives us a tangible metric for scientific creativity that goes beyond basic text evils.
I want to leave you with a cascading implication of this research that wasn't directly addressed in the paper but feels kind of inevitable.
Okay, what are you thinking?
Right now, we're looking at how LLMs behave when we ask them to brainstorm. But human researchers are increasingly using these tools right now to help write their own grants, outline their own papers, and brainstorm their own methodologies.
That's true. It's becoming very common.
So if these models heavily bias toward safe synthesis, and humans are relying on them for ideation, do human researchers eventually start mimicking the AI?
Yeah.
Could we inadvertently train a whole generation of human scientists to stop using wrenches and start playing Mad Libs simply because the AI consistently told them that safe derivative synthesis is what a highly coherent research proposal sounds like?
No.
It's basically a self-fulfilling prophecy of scientific stagnation, all driven by a hidden mode collapse in our alignment data. Just something to think about the next time you ask an LLM to help you brainstorm.